What I'm going to do is just do a quick example showing this idea of what's going on when we screen things and then rank them, just so you can see how we would do this using a database. And we're going to be using the Granta Edupack program quite a bit, and I'm going to show you how to download it, and we're going to go through various exercises with it. So just bear with me if you don't follow what's going on, although I suspect many of you have used this before. So we're just going to use the level 2 database. It has enough materials to do what we want, and we're going to select all materials, and then we're going to go up and press this chart and select. And again, if I'm going fast, it doesn't matter because we're going to be going over this stuff more in the future. And what you see on the left-hand side is lots of different materials. There's about 100 of them. You can see here 100 material records. So this is for the visor. So let's go back to our visor example. And so what we can do is to screen. So this is the part where we're just doing the screening. We're not ranking yet. We're going to use the limit function. And I'm going to go to optical properties. And I'm going to say that the transparency has to be either transparent or have optical quality. And again, you probably can't see what I'm pressing here, so just take my word for it. I've clicked boxes for transparent and optical quality, and then I'm going to apply this, and usually I have to press it twice for whatever reason. And what I want you to notice is how the list is much shorter, and it has borosilicate glass, ionomer, polycarbonate, polymethyl methacrylate, silica glass, soda lime glass, things like that. So the next thing we want to do is, now we've screened out things that aren't either transparent or of optical quality. And so I want to do the ranking now. And so I'm going to go to the chart stage over here. And I'm just going to do a chart. Remember, we said we want to maximize safety. And we kind of define that as maximizing the fracture toughness. So under category here, I'm going to look at mechanical properties, and the attribute I want to look at is fracture toughness. And I'm going to go OK. And what you're going to see is all the material records for these 100 materials. And we can go up here and hide the failed records. And that's going to leave us with a plot of, basically it just shows fracture toughness for all the different materials that are in that left-hand column. And so you can see I have a fair number of materials to select from, and now I have a ranking. So I can see that this polyactide PLA has the highest fracture toughness, and the lowest one, depending on which bar you want to use, would either be polyurethane, which is kind of weird. I don't think about that as transparent. So you have to also, not all of these records are perfect. In fact, I think there are a couple of materials missing, like polystyrene. And Granta is aware of that, and that's going to be fixed in the next update, but that's another story. And borosilicate glass, which it wouldn't surprise you to hear that borosilicate glass has the lowest fracture toughness. So I'm going to do a couple of more things before we make our choice. The first thing is, since we have so many materials to choose from, I'm going to go back to my limit, and I'm going to modify the optical properties to just do optical quality. So I want to, I'm not sure how they define optical quality, but we'll just do that. And then we can go back and look at our plotting stage. So now it's narrowed down to just 3 materials, silica glass, polymethyl methacrylate, which is also known as plexiglass, and polycarbonate. And also I'm just going to go back to the chart settings, and I'm going to take my y-axis and just have it between 0.1 megapascal root meters to 10 megapascal root meters for fracture toughness. And that just makes things a little bit easier to see what's going on. And so there's my polycarbonate, polymethyl methacrylate, and silica glass, and now I have a ranking. Now I can see that of the ones that are optical quality, polycarbonate is going to give me the highest fracture toughness, and so that would be a good choice. We might have to bring in cost and other things into it. And also we could put in the manufacturability. We could have gone back to our limit stage, for example, and look at materials processing or the manufacturing side of things. Let's see, I'd have to, we'll save that for another day. For example, I could have put in something about whether it's formable, right? And I know all of these are formable materials, so it's not so much to worry about. But when you look at metals, for example, you want to examine the degree of formability, and we'll do that in a future time in class.